Hello and welcome to the second film in our roof waterproofing series. In it, we discuss the various layers that go to make up a warm roof. Every warm roof starts with the load-bearing structure. It can be made of reinforced concrete, wood or steel. Reinforced concrete flat roofs are constructed either as solid flat slabs or beam-type floors. Timber roofs are traditionally constructed by laying sheathing or wooden boards on joists, though in recent years the use of solid laminated timber has become more common. Steel roofs consist of corrugated steel sheeting fitted on metal girders. All of these three construction types have one thing in common: they consist of a load-bearing surface upon which the subsequent layers of the flat roof are laid. The most common type of load-bearing structure for a flat roof is the reinforced concrete slab. Whether it consists of a simple solid flat slab or a reinforced concrete slab on beams, it provides a flat concrete surface upon which the various layers of the warm roof structure are built up step by step. The first layer to be placed on the reinforced concrete slab is a vapor barrier. It prevents residual moisture in the concrete and humidity from inside the building from penetrating the insulating layer, stopping at the waterproofing layer, and then forming condensation in the colder upper zone of the insulation material. The sheets of vapor barrier, which must be laid without any gaps, are secured using adhesive tape. They also provide an emergency waterproofing layer while roof construction is in progress. After the vapor barrier comes a rigid insulating material which is laid in panels. Butt joints between the panels constitute weak points that can lead to heat loss, so panels are commonly laid in two layers with offset joints. This not only covers the joints in the first layer, it also divides the insulation into a lower base layer and an upper tapered layer. The insulating panels in the upper layer are produced to a layout drawing so that once laid, they create the specified minimum pitch of 2%. The insulation is followed by a waterproof layer in the form of sheets of bituminous or plastic membrane. The joints between the sheets are sealed using an adhesive or by torching. This membrane is laid in a single or double layer depending on the material and the specification. It is placed loosely over the insulation rather than being taped or bonded to it. This waterproof membrane is the only water-bearing layer in the structure, so any defects will allow water to soak through the entire insulating layer. Because the loose waterproof membrane can be lifted up by the wind, it must be weighed down with ballast. This may be gravel or other loose stone. On a roof terrace, this function is performed by some form of cladding laid in a bed or on spaces. With a green roof, the substrate provides the ballast. The type of roof we have described here is referred to as a warm roof because the water-bearing layer lies directly on the warm layers of the roof structure. The interior of the building is heated, and the insulating layer slows the transmission of heat to the outside. The temperature at the outer surface of the insulation remains above the temperature of the cold exterior air, with the waterproof membrane close to the warm area. Summary: the load-bearing part of a warm roof can be made of reinforced concrete, wood or steel. The most common type of load-bearing structure for a flat roof is the reinforced concrete slab. After this reinforced concrete slab comes the vapor barrier, then insulating material in the form of rigid panels. The insulation is followed by a waterproof layer in the form of sheets of bituminous or plastic membrane. The joints between the sheets are sealed using an adhesive or by torching. Because the loose waterproof membrane can be lifted up by the wind, it has to be weighed down with ballast. Please take a look at the third film in our roof waterproofing series, in which we explain how a cold roof is constructed.